all, welcome back to Level Up. I am Priyanka and today we are going to start with the first chapter of grade 8 mathematics. This chapter is called rational numbers and this video will cover the first part of the chapter. The succeeding parts of this chapter will be uploaded soon and the links will be given in the description box. Okay, now before we start off with the chapter, I want to talk about math in my life. Often math is the most hated subject among students and believe me, I was one of them. I wouldn't say I love learning math either. I like learning new mathematical concepts, but I have never liked literally learning how to solve questions. But now in 11th grade, I really like doing math, and I realized that the basis is only to understand the concept thoroughly. So for the next couple of videos, we will entirely focus only on understanding the basic concepts of the chapter rational numbers. After we are done with understanding the basic concepts, we will move on to solve some questions. Now, before we move on to know what rational numbers are, it's very important to know the different types of numbers there are. So, the first type of numbers are the numbers we dealt with in kindergarten, which are the counting numbers. These include all numbers above 0. So, it starts from 1, 2, 3, 4 and goes on until positive infinity. The second type of numbers are the whole numbers, which are basically just counting numbers but with 0. So, all numbers are 0, 1, 2, 3, 4 and moves on until positive infinity. The third type of number is integer. Integer is any number which is written without any fractional component. So it can range from negative infinity to positive infinity. Examples are -2, -1, 0, 1, 2, etc. Except that these numbers cannot be written in any fractional form or in a decimal form. So for example, -2/3 is not an integer. It is a rational number. That's where we need a new type of number called rational numbers, which are basically just integers which are written in a fractional form. So -2/3, which is not an integer but does not fall under natural numbers or whole numbers, falls under the category of rational numbers. Now, when you go to senior classes, you will learn a new concept called set theory. Then you will clearly understand the diagram in front of you. But for now, this will help us understand an important point that all natural numbers are whole numbers, but this is not applicable vice versa. Similarly, all whole numbers are integers and all of the above are rational numbers. We shall see how all of these numbers are rational numbers soon. What is the necessity of different types of numbers? Now, as we solve questions, we will end up with either one or two equations which we will have to solve. These solutions will have to be represented in different ways. Now, to understand this concept, we shall look at some examples. For this equation, we have an answer of positive 11, which is a simple natural number. For the second equation, we get an answer of 0, which is not included in the set of natural numbers, but it is included in the set of whole numbers. So this answer falls under the set of whole numbers. For the next equation, we have an answer of -13, which is not present in the sets of natural numbers or whole numbers, but is present in the set of integers. Now, for the fourth and the fifth equations, we cannot find out the solution using simply the sets of natural numbers, whole numbers, or integers. The solutions for these equations will be 3/2 and -7/5 respectively. These answers falls only under the set of rational numbers. So, to solve different types of equations, there are different types of numbers. Now, what are rational numbers? A rational number is literally any number that can be expressed as a fraction of p/q, where p is any integer and q is a non-zero integer. It is necessary for q, as in the denominator, to be a non-zero integer, as it is impossible to divide a quantity from 0. We will see why this is the case. Here, as you can see in the image, all parts are divided from either out of 2 to even 8 portions. This is even possible for dividing from 1. But when there is nothing to divide from, you can't possibly take anything from it. That is why the denominator cannot be 0. Now we will be moving on to look at the different properties rational numbers follows. The first property is the closure property, which basically tells that when we perform a mathematical operation on any set of numbers, the result belongs to the same set of numbers even when the numbers are interchanged. For example, when we add 1 and 2, we get 3, which belongs to the same set as 2 plus 1, which is the same set of natural numbers. So we shall look at this for rational numbers. Is addition closed under the closure property for rational numbers? Let us look at the given example. Here we are adding negative 1 by 2 with 3 by 4, and as a result we are getting 1 by 4. When we interchange these numbers, that is add 3 by 4 plus negative 1 by 2, we get the same answer of 1 by 4, which means that the answer remains in the same set. For subtraction, let us look at the given example again. Though we get the negative value of the same number, they belong to the same set of rational numbers, so subtraction is closed. For multiplication, we get the same answer however we jumble the factors, so multiplication is closed. Now let us come to division. When we consider any number other than 0, like the example given here, division is closed, but we need to consider 0 also as a number. Any number divided by 0 is not divisible, so it does not fall into the set of rational numbers. Since the quotient will not remain in the same set, division is not closed. That brings us to the end of part 1 of the chapter Rational Numbers. As already mentioned, the subsequent parts of this chapter will be uploaded soon. If you like this video, please show it to us by clicking on the like button and subscribe to our channel if you find our videos helpful. If there are any queries, you may put it here on the comments box or you may send us a mail given in the description box. Thank you and happy learning.